Welcome to the project demonstration of Ferdowsi rectifiers, single phase buck boost bridgeless power factor correction rectifiers with low semiconductor count. So generally when we are converting AC to DC, we need to use the rectifiers. So in that rectifiers there are two types, one is a bridgeless and one is a bridge. So the bridgeless nothing but using MOSFETs we are going to convert the AC to DC. And coming to the rectifier bridge one, so there we are going to use the either IC DB107 or 4 diodes. So the DB107 come with a IC version of 4 diodes. So in that one they need to use a bridge rectifier, that's called the bridge rectifier one. And bridgeless nothing but using the MOSFETs by switching the frequency based on the input frequency. So if we provide 50 Hz AC signal, then we need to switch the two MOSFETs, one MOSFET for the negative and another MOSFET for the positive off cycle. So we are going to switch them with the same frequency. Then only these MOSFETs will convert the AC to DC without any loss. So the next feature is like coming to the in AC to DC. If you want to convert the AC 230 volts to, for example, 12 volts pure DC, then we need to use MOSFETs along with bridge rectifier and inductors to maintain the current also. So then the complexity will be increases to convert AC to DC with high current ratings. So in our project we are developing with less components as a proposed version of Ferdowsi rectifiers in that bridgeless one. So the bridge, this is going to be the bridge one and this is the bridgeless one. So now we are going to compare the two voltages along with fluctuations. So in bridge one how much of the voltage fluctuates, and in the bridgeless one how the voltage fluctuates. So for comparison purpose we are going to provide these two input outputs to the voltage sensors. So there we are going to use a 10:1 potential divider circuits. So these two given as input to the A0 A1 pins. So the controller will compare the values and continuously display the data on this 16:2 LCD screen, which is connected at A0 or B2 pin number B2 to B7. And next C1 C2 pins are connected to these two MOSFETs. So here, so when the positive off cycle approaches, so this MOSFET will get switched on and will get the positive waveform to the outputs. At the same time this will be off state only, and the next for the negative off cycle this will be off and this is going to be the on. So in reverse bias we will get the voltage of negative current also. So then we will get the total positive current and the negative current. So that we will get the pulsating DC, and with the help of these capacitors we are going to convert that pulsating DC to the pure DC voltage. As usually we know that the bridge rectifier consists of 4 diodes. Will convert the AC to pulsating DC, and the capacitor will provide us pure DC voltage. So the main difference in these two is, so with the help of this bridge rectifier we can get pure DC after the smoothing capacitor, but there may be loss of voltage. Each diode will consume the 0.7 volts, as we know that the junction diode will drop the voltage of 0.7. So at a time 2 diodes will work, so we will lose 1.4 volts around by using the bridge rectifier. And coming to the bridgeless one, so using the MOSFET gates there is no loss of voltage, so minutely loss of voltage. So then there is less loss in this Ferdowsi proposed bridgeless rectifier, and in this one bridge rectifier one. So let us see the demonstration. So just we are going to provide the 230 volts AC signal to the transformer. The transformer will step down the 230 volts AC to 12 volts AC. So generally this proposed circuit will work for 230 volts AC also, but for demonstration we are making that for 12 volts AC only. So this 12 volts AC parallelly giving input to this bridge rectifier and bridgeless rectifier. So the output from this bridge rectifier given as input to this voltage sensor, and the same thing here the output was given, this is the output section, and these two are the triggers. So here the output is given to the same potential divider circuits. So let us see that. So initially welcome message on the LCD screen, and after that we can see the voltages. So the F are nothing but Ferdowsi rectifier voltage, and B are nothing but bridgeless voltage rectifier. So we can see the fluctuations at bridge rectifier. Right.